All right, welcome back. Today we're going to look at partial fractions. So partial fractions are just like these, and if we wanted to combine this into one fraction, we would find the LCD. So we'd multiply the first fraction by x plus 2, and then the next fraction by x minus 3, and write that all over x minus 3 times x plus 2. We would multiply and distribute the, in the numerator, and then eventually combine like terms. Let me write it over here, and we would get x plus 7 over, and we could FOIL this out, we get x squared minus x minus 6. So this is a rational expression right here. And the rational expression can be written as the sum of two or more simpler fractions. So what we want to do, we actually want to go backwards now, and given one of the rational expressions, we're going to write these simpler fractions. So let's look at the decomposition. So here we have the same problem, x plus 7 over x squared minus x minus 6. And if we remember, that factored into x minus 3 and x plus 2. Now, when we have those two factors, we want to separate them and to make them into simpler fractions. So we're going to write this one fraction with x minus 3 in the denominator, and then our second fraction with x plus 2 in the denominator. Now, these are linear factors, so we're going to have 1 degree less in the numerator. So I'm just going to write the variable a. And since we have a second fraction with a different linear factor, I'm going to make that over b. So we have a over x minus 3 plus b over x plus 2. And we're going to solve this by multiplying both sides by x minus 3 and x plus 2. So we'll be left with x plus 7 equals a times x plus 2 plus b times x minus 3. Now to solve these, we're actually going to plug in numbers that would make one of these variables cancel out. So if I look over here, if I plug in a negative 2, so I let x equal negative 2, and I plug it in for every variable here where x is, well, I'll get 5 equals, the a will cancel out, that'll equal 0, b times negative 5. So when I divide by negative 5, b will equal negative 1. Now let me look at the second parenthesis. So over here, if I plug in a 3, so if I let x equal 3, I'll get 10 equals a times 5. And divide both sides by 5, I'll get a equals 2. And so if I wanted to rewrite this decomposition, well, I could plug in my a for 2 equals 2 in for a, and I could plug in my b equals negative 1. So let me put them back together. So we have x plus 7 over x minus 3 times x plus 2 would equal a, which is 2 over x minus 3. And since this is a minus, I'll change this plus sign into a minus 1 over x plus 2. All right, so reflecting back on what we did for the warm-up, you can see that's what we had for the warm-up. So we just went back and forth, starting with the simpler fraction, finding the rational expression, and now we have the rational expression, and we're using partial fraction decomposition to write the simpler fraction. Okay, let's look at the next example. All right, we have 3x plus 1 in the numerator, and it's already factored in the denominator. So we know that those are two distinct linear factors. So I'm going to set them up as separate, simpler fractions. And since we have the first one, I'll write that with an a in the numerator, and our second one will be b. So when I solve it, I'm going to multiply by x plus 5, x plus 12, and we can see right here, we can again find some values that'll eliminate a variable to make our equations simpler. So the first one, let's let x equal negative 12. So we'll get negative 36 plus 1 equals b times negative 7. The a canceled out. This is negative 35. And then if we divide by negative 7, we'll get b equals 5. All right, to cancel out b, we need to let x equal negative 5. So that's going to be negative 15 plus 1 equals a times positive 7. So this is negative 14 equals 7a, so a equals negative 2. So if we rewrote this, this will be 3x plus 1 over x plus 5 times x plus 12. And our a was negative 2. That was over x plus 5. And our b was 5. So we completed our partial fraction decomposition. All right, now let's go to a problem where we have repeated factors. So whenever we have repeated factors, and these are repeated linear factors, we're going to actually use a very similar method. So here I'm just going to make sure we factor out, or just factor the denominator. So we know that we have a GCF of x. I'll write this clear. And so when I factor out the x, we'll have x squared plus 2x plus 1, and this factors into x times x plus 1 squared. So we can see right away that our x plus 1 squared will be our repeated factors. So let me write this over here. So this is 5x squared plus 20x plus 6 over, and I'm going to write the factored form, x times x plus 1 quantity squared. Now our first factor is x. Our second factor will be one of those x plus 1 factors. And we need to make sure we have the degree 2 because we have x plus 1 squared. Now, before we do that, we talked about this will be a linear factor, so that has a numerator of a. This is a different or distinct linear factor, so that will have a numerator of b. And c is based off a repeated factor. So because it's a repeated factor of a linear factor, we can just leave c in the numerator. So we're going to have 3 simpler fractions. And in case, and this happens sometimes, your numerator equals 0, then you actually would eliminate that simple fraction. So instead of 3 in this case, you would have 2. Okay, so for both sides, we're actually going to multiply by the x times x plus 1 squared. So that's going to leave 5x squared plus 20x plus 6. And we'll have a times x plus 1 squared, bx times x plus 1, and then the c just needs another x. All right, from here, just some simple algebra. We're going to have to simplify this, and that's supposed to be x plus cx. And I'm just going to distribute this, so this is ax squared plus 2ax plus a plus bx squared plus bx plus cx. Okay, so in the last problem we were able to eliminate some of these, and we could do that over here. Okay, so you could use -1 and you could use 0. Okay, but I'm going to show you another method, which is grouping. So in this problem, we have a 5 that's in front of the x squareds, and you can see there is going to be an ax squared and a bx squared. So I'm going to put those together. So a plus b x squared. And then for the x's, we know this is 20x. So I'm looking at any terms that just have one x. So we can see right away that if I put 2a plus b plus c times x. And then the last term, I'll put over here, the constant is 6. And we only have one constant. So I'm going to put plus a. Now I'm going to use these coefficients and the constant to write the equation. So when I look at the first one, we know that a plus b has to equal 5. We know that 2a plus b plus c has to equal 20. And then we know that a equals just c. There's no other variables. So working backwards, I could see that if I plug in a for here for 6 for a, we'll get 6 plus b equals 5. So b must be equal to -1. And then I can plug them all into that last equation to find c. So 2 times 6 minus 1 plus c equals 20. That's going to be 11. So my c is 9. So if we're going to write the partial fraction decomposition, well, this would be, let me just write the original, 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x. I could have written the factor form as well, but this will be 6 because a was 6 over x. Our b is -1, so I'm going to put a minus 1 over, the first factor was x plus 1. And then plus 9, because that's our c, over x plus 1 squared. So we're able to write those with simpler fractions. All right, let's look at another one where we have repeated factors. So again, we're going to set it up. So that one factor is shown in the first fraction. So that's just going to be x plus 2. And then we'll have x plus 2 squared. So this is the first linear factor. This is the second linear factor. We're going to multiply by x plus 2 squared. So this will just be b. And then we have -5x plus 6 equals 8 times x plus 2. So from here, you can do that. You could still use values that would make this equal to 0. So we have, or you can solve it using the coefficients. So solving the coefficients, just for practice, we can write these together, but we're going to have -5 equals a. And then we're going to have 2a plus b equals the constant. So if I plug in -5 here, in for a, we can solve for b. So b would just equal 16. So when I write the partial fraction decomposition, it's negative 5x plus 6 over x plus 2 quantity squared. Our a was negative 5, and that was over x plus 2. And our b was 16, and that was over x plus 2 squared. All right, now let's go to the next one. So for this one, we're actually going to look at linear factors and quadratic factors. So when we have x cubed plus 4x, we need to first make sure we factor the denominator. Okay, so we know that we'll have, I'll write this over here, so 3x squared plus 4x plus 4, and that's going to factor the denominator just by the GCF, and we get x squared plus 4. Now we want to keep those fractions, those denominators, irreducible over the rationals. We want to make it easy for ourselves. So the first factor is just x. So we know we're going to have an a. Well, the next factor is a quadratic factor. So we need to have 1 degree less in the numerator. So we're going to have bx plus c. So that would make it a linear factor above the quadratic. Now let's solve this by multiplying by the denominator. So 3x squared plus 4x plus 4 would equal a times x squared plus 4 plus bx plus c times just x. So we'll get ax squared plus 4a plus bx squared plus cx. So again, we can put the a and the b together, a plus b, x squared, because they both have the x squared. We have one variable for the x and one constant. So when we write the equations to match them up, we know that a plus b has to equal 3. That's the number or the coefficient in front of x squared. We know that c has to equal 4. And then 4a equals 4. So a must equal 1. All right, so when I plug in 1 for a, you can see really easily that b is equal to 2. So our partial fraction decomposition, well, this was 3x squared plus 4x plus 4 over x cubed plus x. So we're going to have 1 over x. And then our b was in front of the x. Our c was the constant there. And that's going to be over, I'll just write that as x squared plus 4. Okay, here we have another repeated quadratic factor. So let's set this up. So we have 8x cubed plus 13x over x squared plus 2 quantity squared. So our first quadratic factor will be x squared plus 2, and our second will be x squared plus 2 quantity squared. Now remember, we want to have a linear factor in the numerator of a quadratic factor. So here we're going to write this as ax plus b. Now this is a repeated quadratic factor, so the numerator will be cx plus d. All right, let's multiply both sides by the denominator. So we get 8x cubed plus 13x, and that's going to be ax plus b times x squared plus 2 plus cx plus d. Now a little bit of foiling. We get ax cubed plus bx squared plus 2ax plus 2b plus cx plus d. Now I'm going to make sure I put these in order, but we only have one ax cubed and one bx squared. So we have these two x's, so that's going to be plus 2a plus c times x, and then our constant will be 2b plus d. So let's set these equations. So the first one, and I'll write it over here, we have 8x cubed. So we definitely can see right away that a equals 8. And then b will have to equal 0 because there's no x squared. 2a plus c will equal 13. And then 2b plus d will have to equal 0. So if we plug in a, we'll get 16 plus c, so c will equal -3. And then if I plug in b, well then d just has to be 0. So writing this out, we had 8x cubed plus 13x over x squared plus 2 quantity squared. And in our first fraction of x squared plus 2, our a was 8, but our b was 0. So that means that there will be no constant. It'll just be 8x. And then for c was -3, but d equaled 0. So in their second fraction, it'll be -3x over x squared plus 2 quantity squared. Here we have another repeated factor. Again, we want to set it up. So we have 3x squared plus x over x squared plus 1 squared. So go ahead and try this one, and then pause this video and come back and check your answer. So hopefully you are able to pause it. The setup is very similar to the last one. So we have x squared plus 1 and then x squared plus 1 quantity squared. We'll have ax plus b. That's going to be cx plus d. Multiply both sides by the denominator, and we get ax plus b times x squared plus 1 plus cx plus d. Now here's a little bit of foiling. So you have bx squared plus ax plus b, cx plus d. Again, we're going to match these up. So on this side we have no x cubed. So I'm just going to write this one more time here because I want to make sure that I get the x's together. So a plus c and then b plus d. And then when we match them up, well, I know that a has to equal 0. Okay, there's no x cubed. And then we can see that b has to equal 3 because that's the coefficient of x squared. A plus c must equal 1. And then d, or b plus d rather, would be equal to 0. So if I was going to plug in 0, we know that c would equal 1. And then when I plug in 3 for d, we know d would equal -3. So for this one, I'm going to rewrite it here. This is 3x squared plus x over x squared plus 1 quantity squared. Our first fraction will not have an x because a was 0. So it'll just be 3 over x squared plus 1. And then the second fraction, that was x squared plus 1 quantity squared. The c is 1, so I'll just put x, because 1 times x is just x. And our d was -3, or -3. Now for our last example, we have an improper fraction. Make sure whenever you have an improper fraction to complete the long division. We want to make sure that we have a polynomial, and then we're only going to use partial fraction decomposition on that remainder over the divisor. Okay, so here, just notice the degree in the top is bigger, so that's why we're going to divide. So let's do some long division first. So we're going to have x squared plus 3x minus 4 as our divisor. And we're going to see how many times that goes into x cubed plus 2x squared minus 1 plus 1. Now we need to multiply x squared by x to get x cubed. This will be 3x squared minus 4x. Now just remember, these signs change when we subtract. So this is going to be minus, this will be a minus, and this will be plus. All right, so that when we subtract going down, things will cancel. These will cancel, and we'll have negative x squared plus 3x, and then we bring down the 1, so plus 1. Now I need to multiply x squared by negative 1, so that's negative x squared minus 3x plus 4. Again, just be really careful with the signs. We're subtracting going down, so that becomes a positive, that becomes a positive, and that becomes a negative. So again, this first term, the x squared plus x squared would be cancel out, and then we get 6x minus 3. So instead of writing x, this rational function, I'm going to write it with the quotient, right? So, but we're looking at the remainder, which is 6x minus 3 over the divisor, and that's what we're going to try to find the partial fractions of using decomposition. So I'm going to do this really quick. I could have done this before, but we can factor x squared plus 3x minus 4 into x plus 4, x minus 1. So my first factor, we'll just have this fraction will be a over x plus 4, and my second fraction will be b over x minus, that's a 1. All right, solving for this one, well, it's a little bit easier than the ones we just did. So we're going to multiply the numerator, or all these fractions, by the denominator. So this will be a times x minus 1 plus b times x plus 4. And we can go back to letting x equal a value to write the equations. So if we let x equal 1, that would cancel out the a, and we would have 6 minus, let me write this clearly, sorry, 6 minus 3, and that would be 5 times b. So 3 equals 5b, 3/5 equals b. And then for the second fraction, let's see, we can multiply or substitute negative 4. So let's let x equal negative 4. So this will be negative 24 minus 3, and then we'll have a times negative 5. And this will be negative 27, and divide both sides by negative 5, so it'll be 27 over 5. All right, so we do get fractional values, but not to worry. So whenever we have the long division, don't forget to include that in your answer. So this whole thing, let me just write it out here. This was x cubed plus 2x squared minus x plus 1 over x squared plus 3x minus 4. And when we completed the long division, we had x minus 1 as our quotient. And then we had 3/5, I'll start with the a, 27/5 for our a. So I'm going to put 27 and then 5 in the denominator, 27/5. And then it was x plus 4 in the denominator of that first fraction. And then for our b, it was 3/5, and that was over x minus 1. So we want to make sure that we write our fractions as fractions, not complex fractions. So if we get a fractional answer, you can see that 27/5 is still evident here. You have the 27/5, and then you have 3/5 for your b. I hope this lesson was helpful, and I'll see you all in class.